Let's begin, may we? I'm going to start with the second page. This one. I'm going to start with the claim in the upper left. Ask the question, what does a test score mean? It says, if you completed the test and received your score, you probably wondered, what does that score mean? So then I give them a specific example. If you have a score of 68, how should that score be interpreted? What does it mean in this context? And what is it indicative of? Well, going across the page, it says the raw scores in and of themselves are not at all useful. They don't tell you anything unless you know additional information. What kinds of additional information might you need? Well, that's in slide 3. It helps if you know what trait the test is supposed to measure. It helps if you know how the scores were computed. Students most often want to know, if this is a classroom test, they want to know, well, what was the high score? Or what was the range? And where did I fit in that range? How am I compared to the group average? All of those are bits and pieces of useful information that help you understand. And if it's a criterion reference test, then you want to know what constitutes acceptable performance. Now, psychologists and educators and testing specialists have attempted to simplify things for us a bit by creating derived scores that are based on those raw scores using some sort of a mathematical transformation. Some of those transformations are rather simple, that you've already learned in your basic stat class, like changing them to percentile ranks. So I've given you examples of various kinds of derived scores. I've listed 5 different categories there. Percentiles have the advantage of being readily interpreted by lay persons, like parents, or teachers who've never had a class in statistics. They can readily interpret a percentile as describing a student's relative standing in the group. So if you're at the 83rd percentile, you know that 83% of the people who in the norm group, their scores were less than yours. So you know you're ahead of them. That describes your relative standing. On the other hand, if your percentile is only 13, you know that 87% of the people in the group did better than you. So that's a way of giving meaning to your score by comparing your performance to the performance of others. Well, Z-scores are a beautiful way to do it. They describe your relative standing in a group by telling how far you are above or below the group mean. The only problem is they involve decimals. Some of them are negative. And people don't like negative scores. So we use another transformation to go beyond that. We use transform standard scores. To get rid of these negative numbers or the decimals, we use some sort of simple transformation. The simplest case would be to multiply each Z-score by 10 and add 50. That creates what we call T-scores. But instead, we could have multiplied by 15 and added 100, and that gives us what we call deviation IQ scores. The mean is 100, and if you know that if you're at 115, you're one standard deviation above the mean. If you're 85, you're one standard deviation below. And if somebody tells you their brother had a score of 175, would say, wait a minute. The standard deviation is 15. That guy is a real outlier. Maybe just a real liar. I'm not sure. But that would cause you some concern. The point is, all of these are ways of describing your relative standing. The same as when you take the GRE score. You get a college entrance examination board score. The mean is 500. All we did was take those Z-scores and multiply by 100 and add 500, and we get this magical GRE score that describes your location above or below the group mean. So if you have 720, you know that you're 2.2 standard deviations above the mean. That's pretty good. But if you're only 450, you know you're a half standard deviation below. And of course they give you percentiles too, so it makes it even easier. They give you both. Well, all of those are ways of describing your relative position in the group. That's what you're giving meaning to your score in the norm reference sense. Some people have improved on those by using stanines. Here's a better way that the Rand Corporation invented, that the government is very fond of. They have the percentile ranks up here have a serious limitation. You can't compute gain because they're like a rubber ruler. They're kind of elastic. They don't have equal intervals. This one solves that problem. So this is a major advantage of this one. And the government really likes that for evaluating compensatory education programs like Chapter 1. I'm going to focus today on this one right here called grade equivalent scores. They were a great idea. Notice I put that in the past tense. They didn't work out as well as promised, and I want you to understand why. They are an attempt to go beyond what these others have done. These are all ways of describing your relative standing in a group. But you have to know the group mean. You have to know the standard deviation. And some people get all edgy when you start to use that word standard deviation. So, to make these palatable to educators, the people who invented them said, let's use something they understand, like a person's grade in school. We'll use that as the reference, the basis, and then we'll compare people to where they are compared to where they ought to be. That's the basic notion here. It was a great idea. It just didn't work very well. Their meaning was supposed to be self-evident and readily interpretable by parents, teachers, even by principals. And they were supposed to provide an easy way to measure growth or progress or improvement from year to year. The problem is they don't work very well for either one of those purposes. They appear to be very easy to understand, but the truth of the matter is they're misleading. And most people misinterpret them because of their apparent simplicity. But we really need to understand how they're computed and what they represent. So let's go a little further here. The purpose is to give meaning to the raw score by showing its corresponding grade equivalent. Notice that each grade equivalent consists of two numbers with a decimal in between. The number on the left designates the grade level in school. The number on the right represents a person's position in that school year. They really represent different months of the school year. Now, they're intended to give meaning by describing each student's performance compared to the average performance. You want to remember that notion right there. we're going to compare Johnny's performance to the average performance of students in other grade levels who took the same test. Notice I italicized that last clause. Who took the same test. So instead of showing how an individual's test score compares to a single reference group, a grade equivalent score indicates which group in a series of different grades that student is most nearly similar to. So let's show that over here in a different way. We give that same test to students in a series of grades. And we compute the average test score for each one of those grades. Now, if Johnny gets a 66, we're going to say that he's partway between the 5th and the 6th grade. We don't know what grade he's in yet. We're ignoring that. We're just describing his performance in comparison to other groups. And that's the basic notion here. So we have to give the same test to a series of grades, and we have to compute their average performance. And we create a scale from that we're going to use. Now, let's go a little further here. You have to understand how grade equivalent scores are computed if you want to understand their strengths and their limitations. By the way, it's easy to understand their strengths. They don't have any. What we really need to understand is their limitations. Now, I may sound like I'm a little overzealous here and a little quick to pronounce judgment, but I'll stand by that judgment. They really don't have any redeeming social value that justifies their continued use. In plain English, the world would be a better place if they had never been invented.
Are you using them today? All the time, huh?
Speak up, Carol. Tell her.
Yes. No strength whatsoever.
But teachers don't understand the other complicated, and they see that, and they tell their parents. I mean, not parents, it's the truth.
They're not as used as they once were, but they're used too much. Any use is too much. Now, maybe I overstated that a little bit, but not very far. So let's learn how they're created. I believe you have this page in your other packet. Let's say that we were interested in how students perform on a 6th grade mathematics test. So we do the best job we can to get a valid, reliable math test. And then we administer it to a large number of students that we're going to treat as a normative sample. They're supposedly representative of 6th graders. And I've plotted the scores here. Now, I've only done this for a couple of hundred students. Ideally, it would be done for a much larger group, several thousand students from all across the country. But look, one student had a score of 91. I'm only talking about this middle column right now. And another student had a score as low as 55. And the mean, or the median, is somewhere in here in the middle. We normally wouldn't expect all the students to score the same, would we? Anybody who's had much experience in the classroom knows that kids differ. And some of them do quite well, and some of them don't do very well, so there's quite a spread. But we give this test to the 6th graders. Then we take the very same test and we administer it to a large group of 7th graders and a large group of 5th graders. Look, the 5th graders, the highest 5th grader only has an 81, and the lowest one is down here somewhere. But look, some 5th graders do better than some 6th graders. Is that surprising, Nancy? We kind of expect that. And notice, some 6th graders did better than some 7th graders. Quite a few of them, in fact. These overlap. Now, if we can, we'll also give it to some 8th to 9th graders and maybe to some 4th graders, so that we get the same test given to all of those groups. Then we go one step further. This is a critical page. It's the same page as the one you just looked at, except for one thing. Come right here to the 6th graders. Is that the same scores? Yeah. 13 of our 6th graders had a score of 75. That turns out to be the median score of the 6th graders. And 13 of the 7th graders had a median score of 83. The number who had that score is largely irrelevant. What we have to do is get the median performance. We could have used the mean, although the median is usually used because it's less sensitive to outliers. You can use either one. You have to have some measure of the average performance of each of those different groups. So this median score of 49 for what, I think this is 4th grade, I can't see it there, and this median score of 64 for the 5th graders, and the median score of 75 for the 6th graders and 83 for the 7th. Those are the essential points that you have to start. You get a measure of the average performance of each one. Now please note something important here. The difference between the average performance is not the same here as it was there. Is that apparent? And it's even closer up here, and closer up there, and farther up. Now we're going to take those medians and we plot them on a chart. Before the invention of Excel, everybody used graph paper to do this. But Excel makes it even easier. Notice on this axis I have the raw scores. Across here I have the different grade levels. So 1st grade, 2nd grade, 3rd grade, etc. Now I only administered this test to 4th, 5th, 6th, 7th, 8th, and 9th graders. That's quite a few to get to take a 6th grade test, but that's what you have to do. And then you plot the median score on a graph like this. Then you connect those lines. Now please note, what information is contained in that line? It's a function. We could derive a mathematical function if we wanted. What would that function tell us? It would describe the relationship between raw scores on the test as a dependent variable and grade in school as an independent variable. You with me? Please note something else. Would you describe that line as linear or curvilinear? Curvilinear. That's because of that decreasing distance we saw between the medians a few minutes ago. Would that surprise you? find that happened? Would you expect it to be linear? If the line was a straight line, that would mean that every year the students gained, the difference between the medians was the same in every year. And in the real world, that doesn't happen. It tends to happen the way it's shown here. Okay? Why? There are a lot of reasons for that. Because the 8th graders aren't much better on 6th grade math than the 7th graders. They're not as better here than those people are. And the 9th graders don't do that much better on 6th grade math. The distance between the improvement from here to here is not the same as it is from there to there. Because we're only talking about 6th grade math. They've been learning other things in the meantime. They're not spending all the time studying 6th grade math in the 8th grade. You follow what I'm saying? All right, now, here comes the interesting part. We do two kinds of inference. Let's advance over here now. We select a point on this axis which describes Johnny's score. So suppose Johnny had a score of 58. Please come straight across there till we intersect this line, and then we drop a vertical line straight down here, and we interpolate. In other words, we estimate. That's a fancy word for estimate or inferring. You learned how to do it once in grade school. Maybe it was junior high. You learned how to interpolate. So he is about 4th grade, 4th month. Now he may actually be already in the 6th grade, but his raw score is equivalent to the average performance of a student in the 4th month of the 4th grade on that test. So all we've done is compared his performance to the average of the other groups, and we've located him on this scale down here. You follow what I'm saying? Now you can do that for every score along here. You can draw a line across and bring it down and get the corresponding grade equivalent. For some of these up here, 2 raw scores are going to have the same grade equivalent. In fact, sometimes 3 or 4 of them. Just because they're so close together on this line over here. That's the basic principle of how you make this conversion. We draw a horizontal line straight across, then we drop a vertical line, and then we interpolate. That's the process of estimating unknown values that are located between 2. So we interpolate in between here. Now look, in other words, we divide this distance into 10 equal intervals. And then we divide that one into 10. But something interesting has happened. That line segment is flatter than that one. So these intervals are more close together. And then we divide this one into 10. And this one is even flatter, that line segment, so these intervals are even closer together. You understand what I'm saying? So we don't have an equal interval scale. That's not a problem unless you're trying to measure Johnny's growth. If he had a 6.3 at the beginning of the year, and next year at the beginning he has a 7.4, there's a temptation to just subtract the 6.3 from the 7.4 and say, he gained more than 1 grade equivalent. Well, I don't like to subtract when I don't have equal intervals. That doesn't make a lot of sense. It's not really a legitimate thing to do. So these are not very useful for measuring gain. There are better ways to do that than using grade equivalent scores. But that's not the most pernicious problem here. I use that word intentionally, I think. The other problem is we're trying to determine whether Johnny's performance is up to snuff, whether he's performing where he ought to be, whether he's up to standard. And that's problematic. So let's go ahead. Oh, we gotta worry about extrapolation first. What does extrapolation mean? What's the difference between interpolation and extrapolation?
Is it sort of an outcome? Interpolation, you have information with sort of input, and then this extrapolation is kind of a final or a sum score.
Not quite. They're both forms of inference. Look, we didn't give this test to third graders. We're going to extrapolate. We're going to project. We're going to make an inference. That's interesting, is that right?
That's where you wanted it?
Planned 3 years ago. So we projected the third graders, if we had given them this 6th grade test, and we hadn't, that their average performance might be right here. Now their variability is probably going to be very different than the variance for these people here. But we can still compute a median, and we can project where that would be. And furthermore, we can even extrapolate up this way. So extrapolation involves going beyond the data we have on the outside edges. We're projecting out here, and we're projecting up here. You follow what I'm saying? We'll come back and see those words again in a little while. Now I've summarized how you do this. You give the same test to a series of students at different grade levels. You compute the average score for each grade. Then you plot those on a bivariate graph. And you draw a line across and down. Then you use extrapolation, both above and below, to estimate the average for grades you didn't test. By the way, I at least tested the 4th graders. Lots of times they extrapolate to this point. They only test here and extrapolate that. And I went up here. Lots of times they extrapolate those two. Then you use interpolation in the in-between points. And then you prepare a score conversion table. You don't have to do all this because the testing company does it for you, and they publish it in the test manual, and they give you a little table like this that you have in your second packet. So you can look up any raw score and find its grade equivalent. So if you have a score of 80, your grade equivalent is 6.6, even though you may only be in the 4th grade. And if you have a score of 82, your grade equivalent is 6.9, even though you might be in the 8th grade on this test, or in school. So this conversion table is very important, and it's prepared for you. It comes in the test manual. Fair enough? So that's how you construct them. Now let's ask some questions about this. What does a grade equivalent score mean? Well, I can tell you what Johnny's dad thinks it means. Johnny's in the 6th grade and he comes home with a score of 8.3. Man, he says, chip off the old block, just like his old man. But the next day he's at the principal's office. He's saying, what are we doing keeping my kid in the 6th grade? He got an 8.3. That's a grade equivalent score. Why aren't we promoting him? What are we doing, wasting his time and our time? We got to help him with that homework. He already knows how to do it. So the parent wants him advanced. Well, what does this mean? It does not indicate that that person can successfully perform 8th grade math. How do we know that?
That's right.
He took a 6th grade test.
We don't have any evidence how he will do on the 8th grade test. All we know is he performed pretty well on the 6th grade test. In fact, he did as well as the average 8th grader did on that 6th grade test. That's what the score means. He did as well as the average 8th grader partway through the 8th grade year, and in fact, in the 3rd month of the year, real precisely, you see. He did as well as the average 8th grader in the 3rd month on the 6th grade math test. But Johnny's dad didn't put that qualifying phrase at the end. He didn't even think of that. People jump to conclusions when they use these tests. So,
That's a question.
yeah,
Why is he still going to get completely to go to radio? I mean, if it was like, if I something you said, we need to try out something else.
oh, I'm not opposed to us doing that. In fact, if you insist, that's exactly what I'll do. We'll get an 8th grade test. And we'll see how Johnny performs on the 8th grade test.
But that's again a bit of a false thing to do because he hasn't made grade training. He might be able to do it, shouldn't have the lessons.
I'm not saying he shouldn't. I'm saying there are other factors we ought to consider. In fact, I'll come to that in just a minute. Let's look at the converse. What if your little Johnny got a 4.8? You going to put him back in the 4th grade? Works both ways, folks. I don't think so. Now, before I go on, what's the answer to that question? Is it reasonable to expect all 5th graders to have grade equivalent scores above 5.0?
It's impossible.
It's impossible.
If the test was constructed correctly, it's impossible.
As the students get more than
Where did we get that 5.0? There was a median. That means half the kids were below that. The 5.0 is an average. Now, if it's mathematically possible for everybody to be above average, then that would work. That reasoning would be okay. You know, I went to school in a little place called Nephi. And we had some problems in our school, but we learned pretty well that everybody can't be above average. That's one thing they succeeded in teaching us. Maybe if I'd gone to Lake Wobegon, I would have been another man. But everybody can't be above average. It's just that simple. It violates the definition of what we mean by average. Is it reasonable to expect students in any grade to earn scores that are above grade level? Same problem. So, there's a common fallacy associated with the use of grade equivalent scores. And that's called the Lake Wobegon effect. What is the Lake Wobegon effect, James?
I'm not sure.
Everybody's above average.
Garrison Keeler, Nancy says. On Saturday, I understand it's on Sundays now, too.
I want to do homework on that.
That's right. You keep on doing it, man. Garrison Keeler has this show on Saturdays at 5. What's it called, Nancy? Prairie Honky Tonk. It's in a fictitious place in Minnesota called Lake Wobegon. I served my mission there, I can tell you. It's a cold place. But in Lake Wobegon, all the men are good looking. And all the kids are above average. And all the women are what?
Strong.
Strong, that's right. All the women are strong, all the men are good looking, and all the kids are above average. Well, that can be true in a fictitious place, but it doesn't happen in reality. And that's a fallacy here. Because those scores are misleading, people jump to conclusion. I'll forego telling that first anecdote. So, what if a parent asks the question, why should my kid be promoted? It may be that on occasion a child should be. Happened to my little sister long after I had left. I didn't have any influence on her, but my little sister had a high grade equivalent score, and so the school promoted her. Worked out well for her. It does for some kids. But I wouldn't base that decision solely on a grade equivalent score. I'd want some more information. I'd want the parent to understand something about grade equivalent scores and what they don't tell you. I want to show the parent that same score expressed in another metric, like a percentile rank. Then I want to explain that there's some other factors that ought to be considered. And if the parent still insists, then let's give him an 8th grade test. And if he does well on that, and if the parent is willing that these other factors are okay, then maybe we ought to promote it. But we don't want to do it solely on the basis of that grade equivalent score. Yes?
Well, I don't understand why you want to give somebody a higher test of things they haven't learned. That doesn't, you know, doesn't say anything cool. It doesn't say if somebody could do it, because they're given an opportunity. It just says, to me that's the way of saying why you shouldn't go to the higher
I did that as the last resort.
Well, I'm suggesting that that's pointless, because, you know, I've actually had this experience. There was 3 in a charter school where they do that with us. And the
I'm
first
not,
year-
look, we differ on that.
Can I explain the story?
Nope, because I'm running out of time. I'll be willing to talk with you after. My problem is I'm running out of time. Now, suppose a school board member says, every kid on the Stanford Achievement Test should be on or above grade level. In fact, let me give you a practical application of this. I'm sure Stan never did this. But sometimes, this is a true story, a principal calls in a teacher. We'll call her Miss Smith. And he says, Miss Smith, almost said sister. Said, Miss Smith, look, we've been really pleased to have you in our school this year. I know it's your first year, and I know you've worked hard. But you know something? We just got your test scores back, and 40% of your students are below grade level. What would you say if you were Miss Smith now? I'd say, well done. Because I would expect half of them to be below grade level and only 40% of them are. Wouldn't we? Look, here's the second fallacy associated with grade equivalent scores. There is a tendency to interpret a grade level as a standard. How did we compute grade levels? Average. What's an average? It's a descriptive statistic. It doesn't answer the question what ought to be, it tells you what is. It describes the current average performance of people in that grade. It doesn't give you any information about where they ought to be performing. So when we treat grade equivalent scores as standards, we're doing something they were never intended to be used for. We're taking something that was a descriptive statistic and acting as if it were prescriptive. And that's not what a descriptive statistic does. It only describes what is. So if a board member declares that, then we need to help them understand what grade level does and does not represent. And that it's not a... See, it's this same Blake Wobegon fallacy again, appearing in a different way. Now, what about a legislator? We currently have in the legislature of the state of Utah a bill proposed by a representative from Salt Lake that children not be promoted from the 3rd grade if they read below grade level. The bill does not specify how grade level is to be determined. That's a strength. In fact, this bill has been submitted in previous years and never succeeded. It's been revised somewhat now. But it still says we won't promote a child unless they're reading at grade level. Half the kids are going to be reading below grade level if you use this definition. Now, maybe there's some other way to describe what grade level is. So I went to my colleagues in this building last week who teach reading, and I asked them, if you don't use a grade equivalent score to determine grade level, what do you do? Well, they didn't have a lot of good answers. They talked about some possibilities, but they felt rather edgy about using them, rather nervous about using them. Maybe the best way would be to use lexicons. Would that work? Anybody familiar with lexicons? Barbara is. That would probably be a better way than any one we've talked about so far. But I would have a hard time supporting this bill. I want to know how they plan to define grade level. And I hope they're not planning to use standardized tests, especially with 3rd graders. So we need to find out how the legislator proposes to define grade level and what would count as evidence that a child was above or not. And you ought to actively discourage them from using standardized test grade equivalent scores to do it. Now, I've got to wrap this up. There are 5 shortcomings of grade equivalent scores. The first has to do with the ease with which they're misinterpreted. The fact of the matter is, their apparent simplicity is deceptive. They do not mean what they appear to mean. Second, they're often mistakenly used as prescriptive standards rather than descriptions of what is. We interpret them as what ought to be. Thirdly, the extreme scores have dubious meaning. Why? Because they're extrapolations. And they have unequal units because of the interpolations. So you can't use them to measure gain or improvement or progress. There's a better way to do that, number 4, by the way. That would be with normal curve equivalence. And furthermore, you can't compare a grade equivalent score in reading with a grade equivalent score in math or some other subject. Because of the differences in the variances, they're not really comparable. And furthermore, a grade equivalent score on the SAT, the Stanford Achievement Test, is not equivalent to a grade equivalent score for the same grade on the Iowa Test of Basic Skills. You can't compare them across different tests. They really don't have much utility. Do I recommend their use? No. I avoid them, and I actively encourage others to avoid. I want them to understand why. What would I recommend as an alternative? Percentile ranks would be one, normal curve equivalence would be another, and at the bottom of that list you want to add Lexiles. Now, if you do decide to use them in spite of what I've said, at least be cautious in the following ways. Do not interpret them as standards. Do not interpret them as indicators of appropriate grade placement. And do not assume that they're comparable across subjects or tests. And then two more. Do not attempt to use them to measure progress. And do not expect each child to show 1 year of progress for each year of school. Those are the reasons why I would actively encourage you not to use grade equivalent scores. There are better ways to do it. Now let's go back to this question. Go ahead.
It seems to be suggesting that that's the way to make sure that somebody doesn't go all the way up to testing on that grade. But I've experienced this when I'm actually on board trustees at child school, the kids at level school, so they go to math, they're able to move up to their grade. And my youngest son started in first grade, and he tested, they have a standard test, and they put him in first grade, but I knew straight away it's not long grade, which is too easy. So, but they put to find out what grade you go in, they try to test him with the grade, each year considered, which is just the first and second grade. It's just between the third grade, it's not easy, they did that test again. But it was obviously straight away that's a silly thing to do because he hasn't studied the stuff for that grade, he can't do it. And so I thought it was very strange, but it actually happened is he did it right, and then he
Are they using an achievement test or an aptitude test?
It's a general math test, but you're supposed to show you can do math that is in the grade you're going to. And I think it's strange to do anyway.
I'm not opposed to us trying to place a child where the child works best. If we can satisfy those other concerns about other factors involving that child. If he's in a non-graded school, especially, we might want to be flexible. But if he's in a graded school, we've got to remember that he's trying to learn other subjects as well as math. And that we want to know how he gets along with other little kids, whether he's making the social adjustments that he ought to. I deal with enough social problems that concerns me. Okay? I'm very willing for us to be flexible in that regard. I wouldn't want us to base a child's placement solely on a grade equivalent score. And that's the main message I'm trying to communicate today. Charles?
You know, if we get these things at home with our kids all the time, where they've taken some reading tests, they come back with a list of books that are supposed to be in their reading level, and it tells them what gives a kind of a grade equivalent. Is that different from what you're talking about? Is that the Lexile? Is that Lexile rather than?
I don't think it's a grade equivalent score like I talked about today. By the way, there are a couple of things I didn't say that I should. A lot of standardized test publishers have tried to quit publishing grade equivalent scores. Some of them have quit because they don't think it's a responsible thing to do. Others continue to do it because they say, well, our consumers demand them. I don't know whether that's a reason or an excuse. But most professionals in the field, and I've given you a bibliography of every source I know of on grade equivalent scores, and there's only one entry on that list that advocates their use. And that's written by H.D. Hoover at the University of Iowa, long associated with the Iowa Test of Basic Skills. And I'm not sure what he hasn't repented now. So if you want to learn more about them, that list is there. And if I have confused you in some way, I'd be happy to.
Have you met with any legislators?
No, not on this issue. I haven't.
You can arrange it, I'm sure. Well, I'm very worried about it because we know the research as far as making any difference, whether you use any score. But the other thing that is a little bit scary.
Can you hear Dr. Livingston?
Well, I'm just saying that that's getting a lot of support from some educators in high places also, the idea of retention. And there's no research that supports that as being a viable alternative.
The research that I know of there is pretty clear that retention is not a good thing to do.
I agree.
But that's an ongoing issue. Well, thank you. This has been
Very.